nonlinear astroseismology. In astroseismology, we look at the motion of... Hi, this is Mohammed Mourabit, and I will talk to you today about the work that I've done over the past few years with Dr. Nevin Weinberg at UTA Department of Physics. We study asteroseismology, which is the science of the internal motion of fluid waves inside stars, and how they generate brightness fluctuations at the surface of the stars that we can then observe. Particularly, we will discuss delta Scuti, which are multi-periodic pulsators pulsating both radially and non-radially, um, and how 1,000 of these delta Scuti were observed by Kepler, showing a lot of large amplitude variation in the brightness at the surface of these stars, and how this cannot be explained by the linear theory of astroseismology. So to remedy this, it has been proposed that a nonlinear direct coupling mechanism can explain these observations. In the past, we have tested this idea by making delta Scuti models and showing that all 14 of these models that are computed exhibit a lot of nonlinearly coupled modes or waves. In our case, we showed that all of these models with different stellar parameters have these nonlinear coupled waves, and that the coupling between these waves is frequent in any of these stars. We then needed to look at a stabilizing mechanism for the growth of the parents that are excited linearly to this nonlinear coupling. So if we look here, basically for the direct coupling mechanism, we have two parent waves that are excited linearly, and they're gonna excite a third daughter wave non-linearly. In order to remedy the growth, the unstable growth of the parents, we propose a mechanism that makes use of both the direct coupling and an additional nonlinear coupling mechanism called the parametric instability, where one parent now excites nonlinearly two daughters. Both of these couplings have been studied extensively, but not so much when they're both at play together. Using this, we can find elegant solutions with all modes being stable, and we can study the evolution, the time evolution of these modes. And it works as a proof of concept of direct coupling and parametric coupling in potentially in these stars. We also see that the second mechanism adds no additional assumption to the system, and therefore, for the same reason, the first mechanism should be present, which is strong changes in amplitude of these modes, these waves. Both mechanisms should be able to apply. We also demonstrate that the relationship that it's observable for the direct coupling mechanism is retained under this mixed coupling system. So overall, we showed that nonlinear coupling is frequent in delta Scuti models and should be observed in these stars. And we've shown a mechanism to stabilize their growth so that we can study them over time. In the future, we will build large networks of these models. Hundreds of waves will be considered to replicate the conditions within the stars. And we're also in the process of analyzing the large data sets of Kepler and TESS in order to find more evidence of this nonlinear coupling mechanism. Thank you very much, and I hope you enjoyed the rest of the presentation at UTA Discover 2025.